Hey everybody, Mr. Smith here. Welcome back. What we're going to do today is to dive into the problem-solving side of how we do physics. So changing motion is one of the biggest areas in physics that we study, and we're going to work on it for a long time in the second quarter. So in this deck, what we're going to do is give you the basic 4 ideas that you're going to need to work successfully inside of this topic and be able to do all the kinds of problems that you're going to see. So to begin with, we've got 2 definitions I'm going to give you. So the first bunch of problems revolve around the high-end Tesla P100D, and these numbers are recent and they're true. So this car can accelerate from 0 to 60 miles an hour, which we converted to meters per second, in 2.4 seconds. So what we're going to do is work through a few examples that relate to these numbers. So first thing they ask us is to figure out the average velocity and the change in velocity. So the first 2 formulas you're going to get are these ones. So A, change in velocity, is something that we write as delta V. And the way we do it, as we do the change in everything, is we know that a delta is thing 2 minus thing 1. So if this car accelerates from rest to 26.8 meters per second, then 26.8 is the second velocity, and 0 is the first velocity. So what do we get when you go from rest to 26.8 meters per second? Delta V is 26.8 meters per second, okay? The V1's not always going to be 0, but this time it is, which makes it super easy to figure out. Okay, second thing is they ask us to figure out the average velocity. So average velocity is always going to follow this recipe. Average velocity is V1 plus V2 divided by 2. Notice there's a difference. The plus sign is going to be used when we average. The minus sign is going to be used when we figure out change in. What's sneaky is if we get numbers that are 0, you can be sloppy and you might make a mistake in your formula and you might get away with it once or twice if the V1 is 0 or the V2 is 0. But it's going to catch you in the long run. So make sure you do this right. Just write out the formula the first few times. Make sure you're doing it correctly. So V average is V1 plus V2, 0 plus 26.8 meters per second, all divided by 2. And we figure out that that equals 13.4 meters per second. Okay, so we'll use those 2 basics in what we're going to do right now. So the second question says if we use the numbers that we were given already, use these facts to figure out the car's acceleration. Okay, so first things first, acceleration is going to be the change in velocity over the change in time for this car. So it's the change in velocity. We just figured it out. It's 26.8 meters per second. What's the change in time? 2.4 seconds. Just go ahead and plug those numbers in, and what you're going to get is this car accelerates actually quicker than gravity, 11.16 meters per second. One of the few production cars that you can get that's actually quicker than dropping the car off of a cliff. All right, next one. Same set of numbers. See if we can use what we figured out already to get the car's displacement. So to get displacement, we use D equals V average times T. So what we've done is we've taken our constant velocity formula, D equals V times T, and we've adapted it for the fact that if you can figure out the average velocity between the 2 velocities, you can still use this formula. So it's a way of channeling simple algebra to handle a complex motion. So V average we just figured out a minute ago. It was 13.4 meters per second. And we're going to multiply that into the 2.4 seconds. And when we do it, we go ahead and get that this car travels 32.16 meters as it speeds up from 0 to highway speed. Okay? So those are all really basic one type of example. The easiest examples you're going to find is where they give you the time and the formula. And so let's look at one where they don't. Here we've got Tesla Model S having to do the braking test. Now the fact is the Tesla models are so quick, and all electric cars are so quick, because unlike gas engine cars, they supply maximum force, called torque, from the instant the motor turns on. And gas engine cars don't do that. So there's a penalty, though, to pay. The fact that the Tesla has big, heavy batteries means that it's heavier than almost all the other performance cars out there. And because of that fact, it really suffers in the braking test. So what we're going to do is read this one. The Model S can slow from 26.8 meters per second to rest in a distance of 41 meters. And to do this problem, what we're going to do is we're going to break out the LEPS. So we've got V1, V2, and they're asking us now for its acceleration. So we're going to write down T and we're going to write down A. So let's go ahead and track all the numbers that they gave us. V1 is 26.8. So they're slowing the car down from that down to nothing. Did they give us a time? No, they didn't give us a time. Did they give us an acceleration? Nope. But they did give us the distance. So the distance down here is 41 meters. And what that does is it tells me out of the two formulas, A equals change in V over change in T, or D equals V average times T, I'm going to always be able to make a choice. So I go to my list and I look at these and I say I could get from these either the V average or the change in V. So knowing that I could get the V average or the change in V, I realize that this formula is no good to me because I don't have the T and I don't have the A. But I do have the distance and I do have the V average, and so I'll be able to go after the T. So that's what I do. So the first step in solving problems where they don't give you T is usually to get the T. So what I'm going to do is do some algebra. So I'm going to turn this formula around. So D over V average is going to equal 41 meters over the V average. We figured it out before, 13.4 meters per second. And when we go and do the division, we're going to figure out that that's 3.06 seconds to slow down from highway speed to rest, which is not shabby for a car, but it's not as good as the other super high-end cars. So acceleration, now we can go get it. We're going to get delta V over delta T, and if we go ahead and really pay attention, delta V is going to be 0 minus 26.8. So delta V is negative 26.8 meters per second. And we divide that again by our new time, 3.06 seconds. And we get that the acceleration of the car is negative 8.76 meters per second or meters per second squared. Okay? That's one of the types of examples where they don't give you time. One other example where they don't give you time is like this. Here we've got a high end, and this is a racing version that's not street legal, of this bike that can accelerate from rest to highway speed with an acceleration that's also bigger than gravity. So what we're going to do is go ahead and put in the numbers that we've got, D, A, T, and take stock of what we do have. So 0, because the bike is accelerating from rest. Highway speed, 26.8 meters per second. And they give us the acceleration now of 10.2 meters per second. So what can I do with it? Well, as we talked about a second ago, the first formula, A equals delta V over delta T, has 3 pieces to it. Here they gave us the A. We can get the delta V from these two numbers, and so we can go and get the time. And that's what we're going to do. So we'll rearrange this formula, multiply delta T on both sides, and then divide by A on both sides. And what I get is delta T equals delta V over A. Okay, so that part's done. The next thing I do is I just plug in my numbers. The delta V was positive 26.8. So V2 minus V1 is 26.8 meters per second over my time, or rather the acceleration, 10.2 meters per second. And we figure out that the time for this thing to accelerate is 2.63 seconds from 0 to 60. Holy cow. To get the distance, we're going to pull out the other formula that we use, which is D equals V average times T, and get to work with that one. So D equals V average, the average of these two, V1 plus V2 divided by 2, we've used it already, is 13.4 meters per second. And now I multiply that by my 2.63 seconds and calculate that. This bike goes 35.2 meters in speeding up. So what you just saw there, be flexible. Big thing, be organized. LEPS means list. So write down your list, get organized. E means equation. So do any algebra if you need to. P, plug in, and don't forget the labels, and then solve. Okay? So bring your questions to class. Thanks for watching. Take care and have a great day. Bye-bye.